Hi, this is Math with Beth, and we are going to look at average rate of change. This is something that typically sounds a lot more complicated than it really is. Average rate of change is basically just asking you for the slope between 2 points. The reason it's more complicated is because we're typically not talking about a line. So if we're talking about something like a parabola does not have the same slope at every point like a line does. So what you do is you end up taking 2 points on that graph and finding the slope of them. So do you see how between these 2 points it would be some kind of negative slope? If you're talking about down here, the slope would be 0 because of the horizontal line. And if you're looking at 2 points somewhere around here, it would be positive. So that's why you always need 2 x values to focus on. So as you see, the equation to find it, if you look at this version, it is just the slope formula. The only thing is we don't always have all of the information right off the bat to use the slope formula. So this is the exact slope formula. Believe it or not, this is the same formula. The only reason it's written different is because it's pointing out that if you only had the 2 x's and you did not have the 2 y's that went with them, you would need to plug the x into the problem here to get the y value that goes with it, plug this x into the equation here to get the y value. That's all this fancier version is saying, is if you don't have the y values, you can get them. Another way you sometimes see this written is f of b minus f of a over b minus a. But again, it's the exact same thing. These would be the 2 x's. These would be the 2 y values you get after you plug in those 2 x's. So we'll see a couple different examples of how you can use this. So one example here is saying Danny hiked 8 miles in 2 hours. Well, if you're familiar with finding out kind of speed, then you would put the miles over the hours. But if you want to think of this as points, this is basically giving you 1 point to 8, because after 2 hours, you want 8 miles. And since we don't have a second point, we're basically comparing it to the point 0, 0. So it ends up being 0 minus 8 over 0 minus 2, negative 8 over negative 2, which equals 4. So you didn't really need to do all this, but if you want to do it with this formula, I'm just pointing out that 0, 0 would be your other point. So the answer, no matter how you think of it, ends up being 4 miles per hour. And that is how we write something per something else. So in this case, the temperature rose from 72 degrees at 3 p.m. to 78 degrees at 5 p.m. So this time we do have 2 different pieces of information. So the points here would be 372, 578. So now using the slope formula, we would say 78 minus 72 over 5 minus 3. We get 6 over 2, or 3 degrees per hour. Okay, so that's just how to use it when you have all the information. But now what you typically see with average rate of change is something like this, where you have an equation and they've given you 2 x values, either by saying x1 is 8, x2 is 11, or they could say something like find the average rate between 8 and 11. Either way, what we have are the 2 x's. So we do not have enough information right now, but since we have the equation, we can find the y values that go with these 2 x values by plugging them in. So we will do 5 times 8 minus 4, 5 times 11 minus 4. So this is 36. and 51. So basically we now have 2 points because we already had the x's. By plugging them in, we now have the y's. So we had to do all of this before we could now focus on what is the average rate of change. So now I'm going to use my slope formula to say 51 minus 36 over 11 minus 8. So we get 15 over 3 or 5. So the average rate of change on this graph between 8 and 11 would be 5. So that is how you do it when you only have the x's. Plug them in, get the y's, then use the slope formula. Let me know if you have any questions or if you need more examples on average rate of change.